Okay, 2.2, day 2, page 2. Sometimes we collect data and we want to be able to work backwards. We want to get the function from the information. So what we're going to do on this side is, given the roots or the zeros or the x-intercepts, what function could they have come from? All right, so one thing to remember is when we're solving, if our factor is x minus 7, then we get x equals 7. So what we're going to want to do is take these and go the other direction. So if x equals 7, then the factor is x minus 7. So we have 2 and negative 3. That gives us x minus 2, x plus 3. Here's how the multiplicity works. Here, x equals 0, multiplicity 3. Well, that gives us an x cubed. Negative 8, multiplicity 2, so that gives us an x plus 8 squared. And these zeros or roots look a little interesting. So because x equals 6 plus root 3, so the factor is x minus 6 plus root 3, and then big parentheses. So each factor has 2 sets of parentheses. All right, so example 2, find a polynomial function that has the given zeros. So the zeros are 0, 2, and 5. So 0 just gives us an x by itself. 2 gives us an x minus 2, 5 gives us an x minus 5. So I like to do the binomials first, so I'm going to distribute the x, distribute the negative 2, so we get x squared minus 7x plus 10. Now I'm going to distribute the x, and we get x cubed minus 7x squared plus 10x. Notice it says f of x equals because it said to find a polynomial function. So f of x equals, if you don't put the f of x, it's not a function, it's an expression, and you don't get full credit. All right, so B, 3 with a multiplicity of 2. So the 3 is x minus 3. Because of the multiplicity, it's squared. Negative 4 gives us x plus 4. Multiplicity 2 squared. So I'm going to square this first and get x squared minus 6x plus 9. I'm going to square this second and get x squared plus 8x plus 16. Now there's a couple ways to do that. There is a pattern for squaring a binomial. Again, excuse me, I don't sing well. Square the first term, square the last term, take the product and double. Square the first term, square the last term, take the product and double. So that's a pattern that you can get, but the pattern comes from the fact that if you square something, it's multiplying it times itself. So this would be x minus 3 times x minus 3 written out kind of like this, and then you're going to do all the foiling like we did over here. This would be x plus 4 times x plus 4, and then you'd have to FOIL it out like we did over here. So it's up to you if you want to FOIL it out or memorize the pattern. Now, I don't know a nice pattern for multiplying these two trinomials, so I'm just going to do a bunch of distributing. So I'm going to distribute the x squared and get x to the 4th plus 8x cubed plus 16x squared. Then I'm going to distribute the negative 6x. So I get negative 6x cubed minus 48x squared minus 96x. Then I'm going to distribute the 9 and get 9x squared plus 72x plus 144. Add all my like terms together, and we get g of x equals x to the 4th plus 2x cubed minus 23x squared minus 24x plus 144. And that's it. So this could have been f of x, g of x, h of x, whatever, but just make sure you put something there so it's a function. Otherwise, it's an expression, not a function. And that finishes up page 2.